line between two lines method. And so in essence, what happens is we have our data set that's graphed, and we try and take two lines and kind of capture all the data within those lines, and then we find basically the average of these lines. All right, so we're going to draw the scatter plot on Desmos by hand or GDC, and by moving the points to estimate the two lines that best captures the data. Okay, and so when I've done this already, I've already got, what I can see is I already have the blue line on the bottom. I have these points selected, and so I go along and I'm going to calculate the slope. So I'm going to take my y values over the x values, and I'm going to go 2016 minus 2007. And so when I do that, I can go in parentheses 22240 minus the 13580, dividing it by, in parentheses again, minus 2007. And I get a slope of 962.2. And so then I'm going to find the equation, y equals 962.2x plus b. I'm going to plug one of the points in, so I'll choose this point, 13580, equal to 962.2 times 207 plus b. And when I do the calculation, I get 962.2 times 2007. So, and then I'm going to subtract that value over, so I'm going to bring that over. So 13580 is equal to 1931135 plus b, subtracted over. And so it's going to be 13580 minus, and I can just go on top of this number and call it back, hit enter, and b is equal to negative 1917555. And so my equation, the bottom line is y is equal to 962.2x minus 1917555.4. And then I should go to Desmos and see if it actually fits on there. And my points are a little bit different, so if I find my points 2007, it was going to be around in 2017, somewhere about here. So I get 1358, a little bit higher, 1358. Approximately there. So when I go y equals 962.2x minus 199 or 191 7555 71235.4, it should fit quite nicely. And if I realize that this point is 2224 in 2016, 22264, I can see that it does actually fit that line, and I've done it correctly. So there's the bottom line. Now I have to come along and also do this top line here. Okay, I have to try and fit this value, make a line here that's going to actually work quite well. And I'm going to recolor this to blue. If I recolor it to blue so we can be consistent. And so now that there looks like it captures the line quite nicely, all the points. And so I have 205, 15, 190. So my two new points here, I'm going to change to green, is 2005. Somewhere here is going to be 2005, 2005, comma, 15190, 15190, and the other point is 2014, 2014, comma, 22330. 2, 2, 3, 3, 0. And then we're going to go and calculate the slope of those 2 points there. So let me take this, move it all down. So finding my slope is going to be the 2, 2, 3, 3, 0 minus 1, 5, 1, 9, 0 over 2, 0, 1, 4 minus 2, 0, 0, 5. And so the key here is to recognize we want to try and capture all the points inside the lines so that it goes in the general flow of the data and all the points are captured above and below. And so we know the line of best fit is in between these two lines. So now if I'm going to go and calculate my slope, I go 2, 2, 3, 3, 0 minus 1, 5, 1, 9, 0. And as I'm doing this, recognize that what I'm doing, there's not just one exact perfect slope you can have for the upper and lower bound. There's going to be lots of different slopes that are reasonable. And that's kind of the idea. We are looking for what is a reasonable slope or line that we can do as best we can. Okay, and so now I have my slope, y equals 793.3x plus b. I'm going to plug a point in. We'll plug in this point that I can see, 15190 equals 793.3 times 2005 plus b. And so b will be 15190 minus, I'm going to multiply those together. I'm doing a bunch of steps in my head here, times 205. And so I'll get negative 1575376.5 is my b. And so my green line is going to be y is equal to 793.3x minus 1575376.5. Go back to Desmos and check to make sure I've done it correctly. 793.3x minus 1575376.5. And I can see it does fit quite well. So now that I have my two lines, in order to find the equation of the line, the next step, I've got both these lines. I want to find the equation of both these lines. I've done that. Now I want to find the average value of the two slopes. So I'm looking to find the line that would basically be an average of these two lines, something like that. And so I want to find the average of these two slopes. So finding the average of the two slopes, I know my slope, we'll call it average, is going to be 793.3 and 962 plus 962.2. And then I divide it by 2 is how I find the average. And so I get 793.3 plus 962.2. And then I divide it by 2. And so my average slope is going to be 877.75. So this is the slope of my line of best fit. Now I also need, the next step is I need to find x bar, y bar, which is the average x and the average y value. And one of the things we can do is we have our data sheet here. We basically want to add up all these points, 2005, 2006, 7, 8, all, and then divide it by however many points I have. But there's a shortcut I can do, is if I type in here average, see average pops up, and I want the average of all of these values. I hit enter, the average is 2010. I'm going to do the same thing for the y column. The average of all of these, I select them all, and I get this value here, and I'm going to round it down to 1 decimal place. And so that is my average x and y value. And so if I take this point, and I'm going to hold on to this point here, let me put it here so I can remember it. So what that's saying is that the point 2010, 7. So if I would look for this point 2010, comma 17363, 17363, 17363, 0.6, I can see it right here. And that's the average of all the x's and y's fits there. And so I use that point and the slope to calculate the line now. And so I take these values here, and I'm going to use them to find, I know my slope is equal to 877.75 x plus b, and I use the average point to find the equation of the line. So I'm going to go 17363.6 equals 877.75 times 2010 plus b. I know that 8775 times 2010 is 176,4277.5 plus b, 17363.6. And so b, I'm going to subtract this over. I'm going to get 7363.6 minus this value here. My b value is negative 1746913.9. And so my line of best fit is going to be 877.75 x minus 1746913.9. And so when I take these values and plug them into Desmos, the line should go straight through the middle, kind of between the two, and through this point here that we've added into there. So if I go y equals 877.75x minus 17469.1313.9. And you can see quite nicely the purple line here does go through the mean point, and it has a slope that's kind of between the two. And so this is going to be my line of best fit. And let's see what the steps say. We've calculated line of best fit, and we're going to rewrite variables that make more sense. I know that this is time and profit. So then I'm going to come here, as opposed to calling it x's and y's, I know that profit is equal to 877.75 time minus 174,691.9. So here is my line of best fit using this method of fit between two lines. And so there is yet another method to find the model of the data.